You're listening to WMPG 90.9 Gorham, Portland, Southern Maine Community Radio from USM. Live from the Orion Cygnus arm of the Milky Way galaxy, this is Scientifically Speaking, a weekly half-hour program devoted to elegant curiosities, and I am one of your hosts, Sarah Chang, and joining me as always is Bernie Rhyme, TJ Starwatcher. How are you, Bernie?
Yes, hi Sarah, very good, thank you.
Bernie is our professor of the astronomy lab at USM and our local protector of the night skies. Reach out to us at WMPG Scientifically Speaking at gmail.com or on Twitter at WMPG SciSpeak. Head to WMPG.org to find the last 5 weeks of archives of all of your favorite shows, including this one. Bernie, what
Yes.
is up in the night sky for this coming week?
Okay, so this will be Friday, May 7th. So we're going to have a waning crescent moon. So basically we won't see it. It comes up around 4 in the morning. So just before the new moon. However, it'll be just a couple days after the peak of the Eta Aquarid meteor shower. So you might still be able to see a few of them. That's a pretty good shower. You can expect 20 or 25 an hour. It's actually related to Halley's Comet. So that's an interesting comet, other than being so famous. We actually pass through its debris trail twice every single year. So it creates the Eta Aquarids on May 5th, and it also creates the Orionids on October 21st. So even though the comet isn't coming back till 2062, we can see little pieces of that comet twice every year. And so that'll be pretty interesting. Most of those are smaller than the size of a grain of sand, and they burn up about 70 miles high, moving something like 30 miles per second. So, I mean, of course, that's what we think of as a shooting star, but it's certainly way smaller than a star. But they go pretty fast, and hopefully you'll still see a few of them, or be ready for it next year. So the evening planet is still Mars, still sets around midnight, and then Jupiter and Saturn are up early in the morning, and now Venus has joined us in the evening sky also. So you can see that setting low in the west well before Mars sets, and then you have about a 4-hour gap until Saturn and Jupiter come up in the morning. So it should be a good week coming up.
Awesome. Thank you, Bernie.
Yeah, you're welcome.
And if you couldn't take notes fast enough, you can also check out the monthly What's Up column in the Portland Press Herald. Today's show, we had the very special guest, Dr. Adria Updike, on to talk about her time at telescopes around the world. Dr. Updike has a PhD in physics from Clemson University and is currently a professor at the Roger Williams University in Rhode Island. She has spent a lot of time with her postdoctoral researcher at the Observational Cosmology Lab at NASA's Goddard Space Flight Center, and her dissertation was on gamma ray bursts as probes of dust in the evolving universe. In this episode, she has spent a lot of time at the telescope in Chile, telescope in Arizona, and also in New Mexico. And this was her insights on what life was like when doing research at those very amazing places. Enjoy. Bernie says that you have spent some time at a couple of telescopes. Or were you there, or were you, was it all kind of remote in Arizona and in Chile?
So when I ran the telescopes in Chile, I was physically there, and the rest of my team was remote. So basically, I was working with scientists at the Max Planck Institute. So I was working at the La Silla Observatory, which is owned by the European Space Agency. So I was not at one of the American observatories. I was the only American on the mountain. Everybody else was German or, mostly German, but people from Europe in general. And we always had a member of the team on the telescope. We'd go out for 3 weeks at a time. We'd do like one night of overlap with the person who was there, give them a chance to sleep before they had to take the trip down the mountain and go catch a plane out. And switch over, spend 3 weeks on the mountain, basically just waiting for these things to explode and otherwise just sleeping. It was really hard to do much else. You're at really high altitude, so it was hard to concentrate on anything. You can't get a lot of work done up there. It was like 7,000, 8,000 feet, which is high altitude for me. I grew up at sea level. The Chileans,
Yeah.
They were fine. The people who lived there, they couldn't understand why we couldn't do anything. They were running around. They went to the gym. I could barely walk up the hill. We walked down to the observatory, which was like down one flight of stairs. And by the middle of the night, lunchtime around 1 a.m., I was like, oh God, I can't walk back up that hill. So I'd bring an apple with me for lunch or something like that.
Did you ever experience any health benefits because, for example, there's I don't know if it's research or if it's just kind of a theory, but there are these institutes that will bring cohorts of people who need to lose weight, and they'll bring them up to high altitude to exercise, and because it, I guess, makes your blood pump, heart beat a little faster. There's something about it that makes you want to, that makes your body work a little bit harder or more efficiently or something like that. And yeah, and so they just track how much, yeah. Or maybe it's just because you're up there and then you just have this feeling of needing to throw up all the time, and so you just don't eat.
I
I don't know which one it is, but I was curious because I mean, 7,000 feet is not too bad, but like 10,000 feet is probably getting to that point, especially if you're there for a while.
Well, maybe they just need to go on the astronomer diet because between being at the altitude and sleeping all day and only working at night, um, usually I was down to like having a cup of soup a day and maybe a piece of fruit or something. I don't know. Something about it just killed my appetite entirely.
Mm.
So I always lost weight at the telescopes, but I'm not sure exactly what it was, if it was the altitude, if it was the weird sleep schedule. Although when I did go and visit the high altitude lakes in the Atacama Desert up near where they're putting they put the big new arrays and everything, the Atacama Large Radio Array, that was around 14,000 feet, and that actually was giving me headaches. Yeah, being
Mm.
up at that altitude, and the sun is so ridiculously bright and glaring at that
Mhm.
altitude. You're up above so much of the atmosphere, you get a lot more ultraviolet radiation hitting you. Yeah, that was giving me headaches when I was taking the trips up there. So I'm glad I'm not working on that telescope.
How long were you physically there for?
Probably in total, maybe 6 months or so. I took a lot of these 3-month shifts, running
Okay.
sitting there night after night, waiting for these things to explode on the telescope. Yeah. And then I
So
also
wait,
went to times
did
as
you live at the telescope or did you live at a lower altitude? Because I would
well.
assume you got acclimated over time, right?
Uh, Not really.
Oh.
3 weeks was not really enough time for me to really get acclimated, it turns out, especially coming from sea level. So, but yeah, they had dormitories up there on the mountain nearby the telescope. So yeah, you just slept all day, got up maybe an hour before sunset or so, ate dinner, and then went and started taking your flats and getting the telescope ready for the night. And then if it snowed or was raining or something, sometimes we'd hang out in the telescope anyway, just in case it broke for the night and we could go do something, or else we'd go back and yeah, use the internet in the dorm room or something, read a book, watch a movie, that kind of thing. Yeah, for about
Yeah.
3 weeks at a time. Yeah. It
Wow.
was really cool. I had unfortunately I had never taken Spanish, and then I spent so much time in South America. I had studied Russian, and that never came in useful. It's cool, but it never came in useful. Yeah, but basically just sitting on the mountain night after night. Fortunately, English was the most common language that everybody had in common between the native Chileans and the Europeans coming over. Most people just spoke some variety of English. So yeah, I got lucky. And then I also
What
ran
was
telescopes in Pitt Peak in Arizona. I ran most of the telescopes on the mountain at one point or another, but I most likely had, or most often had time in person on the big 4-meter dome and the 2.2 meter. And then I ran the Sarah and Super Lotus telescopes remotely. Sarah and Super Lotus both automatically respond to gamma ray bursts, but the 4-meter and the 2-meter only did when I was on the mountain. We had a lot of what we called fill-in targets for the rest of the time. Galaxies we were taking another look at after the gamma ray burst faded. We wanted to go back and see how much of how bright the galaxy was behind it, things like that, and then projects for other people in the meantime while we were waiting for something to explode.
Gotcha. How does it work for you to kind of borrow time on the telescope? Is it like just a scheduling kind of thing? You just request for time, or like how
Well,
does that those logistics work?
yeah. So for the telescope down in Chile, a certain amount of time had been allocated to my group for gamma ray bursts. So we had a certain amount of time we could interrupt, say we've got 3 hours tonight, and then we have to give it back. Basically, the European space or the the ESO had paid for the telescope, and as members of the ESO that I think that just entitled our group to a certain amount of time on it. Usually you have to apply for this time, so we might have had to apply every year to keep our time up. When I was using the 4-meter and the 2-meter, again, my graduate program, Clemson University, had bought into a consortium, so we had a certain number of nights on it a week or a year guaranteed. So we just picked the ones we wanted, and somebody did all the scheduling and decided when we could use it, and we went down. Other ones, we had the Sarah and Super Lotus. We were part of those consortiums. We had bought into them at some point. Other telescopes, you just apply for time and you see if you get lucky. So you tell them why you want to use the telescope and you send in your application, and a group gets together a couple times a year and says, all right, we're going to prioritize these projects that seem like the most likely to lead to something interesting. And these are the people who will get time on the telescopes. But if you want dedicated time over and over again, buying into a consortium is the way to go. Yeah. Or having a friend who did that, who's willing to call them up once in a while and say, hey, could you just turn it around for 20 minutes and take a picture for me? So yeah, which also happened a lot. Yeah.
Any other things while you were down in Chile other than just hanging out at the telescopes?
Yeah. So I could usually justify adding 3 or 4 days to the beginning of my trip or the end of my trip. But the best one was when right in the middle of my 3 weeks, they decided to redo the mirror on the telescope. So they took the whole thing apart, took out the mirror, and they were going to re-silver it. Basically, they were going to redo the covering of the mirror. And it was going to take a week. So I got a week off in the middle of my ship. Basically what I decided to do was take a bus up to San Pedro de Atacama, which is up in the Atacama Desert in northern Chile. Now, basically, these mountains, I was on La Silla, which is, it's outside of La Serena. It's a couple hours outside of the city of La Serena, which is up north of Santiago. So I'd fly into Santiago, get a short flight up to La Serena, and then catch a van up to the telescope, which was a couple hour drive. So San Pedro de Atacama is this little tiny town out in the middle of the Atacama Desert, which basically exists for extreme tourism, I guess. It's people who want to be tourists, who want to go hiking out in the middle of the desert, or want to go and see things that take several days to get to. So it's very outdoorsy types. It's not a typical touristy like Disneyland type place. It's very much a center for people who are going to go take a long trip out somewhere. It's a kind of a central place for them to congregate and then take a trip from there. So it's this cute little town that looks like Santa Fe, right in the middle of the Atacama Desert in Chile. And from there, I used that as a base and used it to take a number of tours up into the Atacama Desert itself and into Bolivia. So it was right on the border with Bolivia. So I got to go and see the high altitude lakes in the Bolivian national parks. That's where you go if you wanted to see Salar de Uyuni, which is basically that very shallow lake in Bolivia, like a couple centimeters deep. And it's that place where everybody takes those photographs where the sky is reflected in the ground for everywhere in every direction. Yeah, you'd start in San Pedro and then you'd take a 3-day trip from there to go to these. I did not go there. No, I went to the high altitude lakes instead, and then a couple other desert trips. I didn't want to take the 3-day trip. I wanted to do a couple of other short 1-day ones. This picture that's my Zoom background right now is it's the Valley of the Moon in Chile. And it really looks like you're on Mars or on the moon, but it's actually a picture from Chile. It's a salt flat in the background that you can see. It was the most incredible place in the world. I have all these absolutely gorgeous pictures. I couldn't believe I had never heard of it before. I looked it up in the tourist book and said, I'm going to go there. So, yeah. And I just took the bus up there and back. And I got to say, the buses in Chile and Argentina are fantastic. It's like a lounge seat that you've got, because you're going to be on it for a long time. The buses are how most of the people get around there. They're very inexpensive, extremely comfortable, because people ride them for, days at a time to get where they're going, which is basically how I got everywhere when I was in Chile and years before when I had taken a trip to Argentina. Unless you're going somewhere that, it was much easier to fly if it's going to take more than 2 days on a bus. But yeah. And it was a great experience. I got to say, I loved traveling around Chile. Southern South America is very much like being in a European country in many ways. It was a great experience.
Yeah, you're lucky. Did you get the chance to go back there in July for the eclipse in 2019?
No. Oh, so in no, I didn't. I haven't been there probably since 2000 2015 might have been my last trip to Chile. It's much harder for me to find 3 months or 3 weeks at a time that I can take off and go down to Chile. And at this point, the team is mostly automated to the telescope. We don't need somebody on site all the time anymore. And the people who are on site need to be able to fix the telescope. And I was not good at that. So every time something went wrong, I'm in the control room. All right, I can see like this light is blinking and I don't know. It's really dark in here. What is this supposed to look like? So yeah,
Do you have
I
to
was
do
not all that
training
helpful.
for that?
I got a couple days, but for the most part, you're just sitting there on the phone trying to describe what's going wrong to somebody in Hungary, and it's like 2 in the morning for you, and it's 7 in the morning for them, and they only barely speak English, and I do not speak German or Hungarian, so you know, it was definitely an interesting time. It was a lot of fun, but I gotta say, I am too old for that now. You know, staying up all
Yeah.
night and then sleeping all day, it was exhausting. It's definitely a young person's game. That's why they send all their
Yeah.
graduate students out there.
But it's got to be a lot of fun. I mean, it sounds like it.
It was a great experience, and I got to see so much of the world I had never seen before. And you know, when you
Yeah.
talk about traveling, not a lot of Americans go down to South America. When I traveled around down there, I very rarely ran into other Americans. Lots of Germans and Europeans and Israelis, but very few Americans. Yeah.
Yeah.
It's too bad. It's very expensive to get down there, to get a flight down there, but it's so cheap to go everywhere and eat and stay places. I could get a hostel room for like $5 to $10 a night, and I'd have it all to myself. So yeah, highly recommend Chile and Argentina.
So these telescopes, did you choose them because they were the only telescopes where you could detect gamma rays? Or is it because you had like your university had were in the consortiums, or could you go to any of the other telescopes around the world?
Yeah, so gamma ray bursts emit light in every part of the spectrum. So you can look at them from any type of telescope you want. There's people who just focus on the radio part of the spectrum. There's people who focus on the X-ray part of the spectrum as viewed from Earth by X-ray collisions in our atmosphere producing showers of particles. You can look at these in so many different ways. I was the group that I decided to work with primarily did visible and a little bit of infrared and ultraviolet observations. So they had specialized instruments on some of these telescopes. So those were the ones that we went to. But telescopes all over the world will contribute to these. So we have a gamma ray. Well, there's the Astronomers Telegram Network, which of course has not been a telegram for a very long amount of time. But gamma ray bursts have their own network. Basically, there's about, or at least to be 6,000. It's probably more now. So an email goes out to everyone that it says in the first place, coming from the telescope team, hey, this is the Swift observatory team. Hey, we saw a gamma ray burst at this location. And then astronomers who have telescope time, who are part of the gamma ray burst network, will turn around their telescopes. And then when they have analyzed their data, which usually we do the same night because you want to be the first person to find it. That's a a really good thing. You're top of the game that night if you were the first one to discover this. So you analyze your data really fast and you send out an email to the whole list again saying, hey, I took this data on this telescope in this wavelength band and I saw this, or I didn't see this at this location. And then other people say, all right, well, I looked at that and I saw this. And you start putting together all this data. So gamma ray burst papers tend to have a lot of co-authors on it because you often pull in people from all over the world who had different data. Because say if a gamma ray burst goes off right now, hey, sure, maybe I can see it from Rhode Island, but somebody in Australia can't see it. But 12 hours later, they'll be able to see it and they'll pick up where I left off. And then I'll come in again the next night. So basically by sending out these emails, you're telling people, I have some data. If you want to write a paper about this one, let me know. Invite me to join you. I'll share my data with you. So that's why we put together these consortiums. One of the ones I was on, the SARA consortium, has a telescope in Arizona, one down in Chile, and one in the Canary Islands. So basically, you can pick it up as it goes around the Earth, and one telescope has to be put away for the night. The next one can pick it up. So the goal for a lot of these consortiums was to have enough telescopes spread around the world that one of them would have good weather and it would be dark at that telescope during the time that you wanted to look at a gamma ray burst. So it was basically building up larger and larger consortiums was the was the goal on bigger and bigger telescopes, because often these things were very dim. Although there was one a few years ago that was technically naked eye bright. If you had been outside looking up at the exact right location, you might have seen it for a second or so. It
Oh,
reached
wow.
5.8 magnitude, so just barely visible. There's no record that anybody actually saw it, other than the camera that grabbed it at the
What
time.
was that? What constellation?
Oh, sorry.
You
Oh,
might,
where was it? Oh, I'd have to look that up. Let's see.
because I
Naked.
could point that out to someone that one happened there. Yeah.
Let's see. So that was gamma ray burst 080319b. So that was 2008 in March. Oh, March 19th. So,
Oh,
a few seconds ago.
yeah.
It was in Boetis.
Okay, great. Yeah, we can see that from here.
You can see that. Yep.
Yeah.
Yep. And it was 7.5 billion light years away. So almost a redshift of 1.
Hmm.
Yeah. And that was I think that is the brightest thing ever observed by humans in the universe, because it was
Wow.
halfway across the universe, but it was still naked eye visible, technically, very briefly.
Oh, excellent. So was it near Arcturus?
Let's see. I'd have to plug this into planetarium program and take a look. But if you look, if you look up GRB 080319b,
Yeah.
the B means it's the second one discovered that day. So
Oh,
yeah.
okay.
So we name them
Oh,
by
wow.
year, the month, the day, and then A, B, C, D.
Oh,
We got to
wow.
E once, but it's very
That'd be a
rare.
neat thing I can point out in my next star party.
Exactly. Yeah, right over there somewhere.
Yeah, right.
If you had been looking at the right time. Yep.
'Cause I saw a quasar about 1 billion miles away, but it was a 17-inch telescope. That's the
Ooh,
furthest I saw.
yeah.
Yeah.
No, we we don't look through these much anymore. They've all got cameras on them, so that's
Yeah, right.
I've never looked through a telescope directly at a gamma ray burst, just through the camera. Yeah.
Right. Good way to do it.
So, you no longer study gamma ray bursts actively, right? But what have you been doing lately? I know you said that something with aquaculture.
Yeah. So my university, Roger Williams University, has a large marine bio program, and we also have an aquaculture program. And if you're not familiar with aquaculture, I know I wasn't before I came here. It's basically shellfish farming. So oyster farmers, clam farmers, scallop farmers, things like that. If you're raising seafood for food, you are in aquaculture. So we're one of the few programs in the world, actually, that has an aquaculture program. And we have so many professors in that field, and nobody else in astronomy at all, only one other physicist. In fact, I might be one of the only 2 astronomers in the state, as far as I know. I was looking for collaborators more locally, because I can't go to Chile as often anymore, and ended up working with my other physics skills. So my PhD is in physics. I took classes in electronics and things like that. So a lot of the work I've done recently is focused on open source electronics. So inventing low cost sensors for a lot of monitoring work. So I was part of a grant a few years ago to build a low cost fluorescence sensor that would sit out in basically an oyster bed region for aquaculture farmers and monitor the amount of algae in the water. So it turns out actually it's very closely related in scope to the gamma ray burst work I have been doing, which was looking at the light from gamma ray bursts to figure out how much dust was in the host galaxy. Now I'm looking at the light from coming in from the fluorescence center to figure out how much algae is in the water. It's
Wow.
actually comes down to the same problem in the end, with a lot of the same kinds of scientific solutions, even though it's a completely different topic.
Yeah.
But hey, science does that to you sometimes. So the idea
Wait, so what is fluorescing?
okay, so basically what you do is if you take ultraviolet light and shine it on algae, the chlorophyll in the algae fluoresces and it lets out a bunch of red light. So you shine a really bright ultraviolet light on a group of algae and it puts out a little tiny bit of red light. You can actually see it with your eyes when you do it. And I built a fluorescence sensor that picks it up on a little sensor. And basically, I shine light at them, they put back fluorescence, and depending on the amount of fluorescence, it try to estimate how much algae is in the water. So it all comes down to the amount of chlorophyll in it. You could do this with spinach. You can do this with spinach.
Wow.
Yeah.
Very
Anything with
cool.
chlorophyll. Yeah.
Was that knowledge that you had prior to, developing the sensors? Or
Basically, I knew some electronics and I liked to make things. And it turns out it's when you don't have a lot of physics majors at your school, it's much easier to bring students in on a project where they're going to build something than it is to
Mhm.
teach them the astronomy and the physics and the math and the computer science they need to get started on your astronomy work. It was a much more entry level type project, much easier to get students involved right away in a project when you're building something. So
Mhm.
that's what we've been doing a lot of lately, is working on this, calibrating this fluorescence sensor
Mhm.
to try to figure out how much algae is in the water. Now,
And
the
so,
reason that you want to know how much algae is in the water is that certain types of algae, not most of them, fortunately, but certain types of algae will cause oysters to produce toxins that can be harmful to humans. So if the algae is in the water in low concentrations, you won't be able to see it with your eyes. This is the precursor to, say, a red tide, like they've been having problems with algae blooms down in Florida and even up here, actually, in the lakes and things like that. When there's a low amount of algae in the water, if it's this toxic kind, it can still make the oysters produce toxins that hurt humans. So if a human eats one of these oysters, they can get sick. In a few cases, people have actually died from eating these. But usually we don't know that the oysters are producing those toxins until somebody actually does get sick from eating them. And then once they trace it back to the oysters, they shut down the bed for a while. Okay, no more harvesting from here for a little while. Now the oysters will work this out of their system. Wait a few weeks after the algae have gone away and they're safe to eat again, because oysters are filter feeders. They just keep filtering stuff in and out. And once these algae are gone, they stop producing the toxin and you can eat them again. So it's just a matter of knowing when it's not safe to eat the algae.
Mhm.
Or to eat the oysters, sorry. It's a matter of knowing when it's not safe to eat the oysters. And it's when this algae is in the water, but usually you can't see it. And monitoring algae is often a pain in the ass. Sorry, probably. Monitoring
That's
algae
okay.
is a bit of a problem. Algae monitoring systems are very expensive. And the other way to do it is basically go down, get a cup of the water and look at it and have someone who knows what they're looking at say, aha, there's a bad one. We don't do that a lot. So usually it's just when it's noticeable in the water or someone gets sick that we shut these down. So the system that we were building was a low-level monitoring software. Basically, it was going to sit in the water, and a couple times a day it would measure how much algae is in the water and report back and send you a text or something when it started looking like there was a buildup of the bad stuff, and then you stop eating the oysters until it goes away again. So that's the idea. It was basically a kind of an early warning system for red tide and algae blooms. And that's what we're working on now. We're working on the calibration, so hopefully we'll be able to start deploying them at some point. The original grant had been to deploy them in places like Panama, where oysters are a major source of protein for the people who live there. Oysters are actually the second most popular food or seafood eaten in the world. So they're a huge
Oh,
source of
wow.
protein and the major source of protein in many countries. So being able to support these cultures where basically they don't have a lot of technology at the moment and they're not noticing this stuff in the water until it gets bad, being able to support them so they know when to eat the oysters and when it's not safe to eat the oysters could be very useful. So that was the
Sure.
original grant that funded us, but we've been going since then on smaller grants, including from NASA, because NASA does a lot of work with geo satellites and monitoring algae blooms from space. We could also use it to help calibrate their instruments if we know what's going on in those lakes, independent of what's going on from the satellite's point of view. Yeah.
Mm. Are algae blooms, this is probably a little outside the scope of your work, but are algae blooms not predictable in terms of like their seasonality? Because I feel like we hear about algae blooms like late summer, early summer, or something like that. I don't know if that's something, I guess maybe in Panama is it a little bit more random?
I'm not sure about that. Around here, definitely they're seasonal. I think they are mostly a seasonal thing. However, the kind that produce the toxin don't necessarily come seasonally, and a lot of them respond to
Mm.
how much certain concentrations of things like nitrogen are in the water. For example, we have an oyster bed right off of our campus, just on the bay. We're right on the bay, the Mount Hope Bay, and we have an oyster bed for teaching purposes on the dock outside my building. Now, the oysters are safe to eat most of the year round, but when there's a lot of rainfall, the sewage plant in Fall River across the bay overflows and the water is bad for a few days and it's not safe to eat the oysters, and then it goes away and they're safe to eat again. So basically, things like that can cause problems if you have a lot of sewage coming out into your water supply, if you have other contaminants getting into the water supply. And of course, global warming as a whole is also leading to more and less predictable algae blooms and more toxic algae. So these are all problems that are causing unpredictable types of algae to start showing up in places. So we need to start a more whole-scale monitoring project. So it's
Are
where your degree will lead you. I never thought I'd be working on this, but hey, often it comes down to, hey, what are you working on? Hey, that sounds cool. Do you need the help? You need some help in this? I can do that. I can
well,
totally.
this is kind of like completing the circle because you were interested in environmental science, right?
That's how I got started. Yeah, I was working at the local
Yeah.
estuaries, actually doing water testing for things like, E. coli contamination in the water. I used to do a lot of those
Okay.
water testing things at the when I was in junior high school. They used to let us get involved in the chemistry labs there, doing the water testing. Yep.
That's awesome. And then I'm also curious, when this might also be a little bit outside the scope of the development that you're doing, but do the aquaculture farms, does it help them implement any interventions or do they just wait?
That's a good question. So some of the stuff could basically what based on what's in the water itself, they might be able to take some sort of intervention, try to stop whatever's causing the contamination. But often it's just going to be a matter of waiting, which
Mm.
could potentially be a problem if that's their main source of income. Some farmers might not want to stop producing, even if it's increasing the chances that somebody might get sick from it. So that's the next problem that we'll have to deal with after that. Once you develop something new and you're like, oh, it's this wonderful technology, it's going to save all these lives. Well, it's also going to make a lot of people mad at you. So it's going to come down to what's the trade-off? And,
Sure.
if we make this technology free and freely available to people, what happens if they don't want to report what's going on? But hopefully that will be somebody else's problem to figure out, not mine.
You've been listening to Scientifically Speaking here on WMPG with myself, Bernie, and Adria. From your favorite nerds, mask up, and we wish you healthy bodies and clean air.